So hello and welcome to another fine edition of Math 140 Science. This is lecture 4, September 9th, and we will be working on the workbook. So we're working on chapter 2. So what we're going to do is we're going to go through these questions. Now, ideally, you all have a copy of the workbook. I know this because I posted it. So I would like to share my iPad so you can see my work. And therefore, I'm going to unshare my screen. Does everyone here have said copy and have something to look at? I hope so. So I'm going to stop share this screen. And I am going to share this screen. Okay. Okay. So let's get started. And the workbook, question number 2.1. Says, E. coli in swimming areas to investigate water quality. The Columbus Dispatch took water specimens at 16 Ohio State Park swimming areas in central Ohio. These specimens were taken to laboratories and tested for E. coli, which are bacteria that can cause serious gastrointestinal problems. For reference, if a 100 millimeter specimen, about 3.3 ounces of water, contains more than 130 E. coli bacteria, it is considered unsafe. Here are the E. coli levels per 100 millimeters found by the laboratories. Find the mean. Okay, so all of that stuff was a lot of who cares, not in practical knowledge, who cares? Obviously, you know, whatever researcher is doing this material, it matters. But in terms of finding the mean, what do I do? What do we all do to find the mean? What should we all be doing right now as I'm talking? Is anyone hearing me?
You add it all and divide it by how many there is.
You add it all up and divide by how many there is, or there are. I don't speak English good, but I'm pretty sure it's R. Maybe I'm wrong. I don't know. So what do you get when you divide it up and divide by how many? Anyone do it? Anyone? Anyone there? Hello? Are people chatting? No one's chatting. No one's saying anything.
Someone said in the chat, but I got 56.28 as well.
Oh, someone did say in the chat. I must have missed that. 56.28, and that's what I get. 56.28. I apologize. I didn't see the chat. I have too many things going on my screen at once. I can't see everything. So let me shift this over a little bit. Okay, 56.28. Now, and that's just doing the math. I mean, there's no deep logic behind this one. You just got to know how to do it. How many of the lakes have E. coli levels greater than the mean? How many have E. coli levels greater than the mean? 3, that's what I get. 3 are greater than the mean. Just count them. What feature of the data explains the fact that the mean is greater than most of the observations?
The outliers.
Yeah, I mean, you got a 291 in there. You got a 190.4. Even the 86 is, I mean, all three of them are a lot bigger than the majority of them, right? So what feature? We got outliers skewing the data. Which way? Which way is it skewed?
The right.
To the right. The mean is pulled to the right. Excellent. The mean is pulled to the right. We got outliers. which is why if I was a researcher, what measure of center would I use for that particular problem? What would I use as my measure of center? Anyone?
Median,
No, not the mean. The mean is bad. The
median.
median, right? The whole, the skewness makes the mean bad. I would use the median. All right, 2.7. Oh my God, that's a lot of data. Here, oh my God, 189 cars. Wow. But you know what? They're already in numerical order, so it's not as bad as it seems. Okay, so the Department of Energy provides fuel economy ratings for all cars and light trucks sold in the United States. Here are the estimated miles per gallon for combined city and highway driving for the 189 cars classified as midsize in 2019, arranged in increasing order. A, give the 5-number summary of this distribution. Of the 5-number summary, what's the lowest of the 5 numbers? Yes, right? Those are the easy ones. Min equals 12. Max is equal to 56. Those are the easy ones. What do we want to find now? What do we look for next? Yeah, of those that you listed to me in a direct message, and you're more than welcome, by the way, to I have a few people who are direct messaging me. If you're answering questions, you're more than welcome to make them public so that other people can see what you're saying as well. It's your choice. I'm not gonna force it. But of those other things that we're looking for, which one in particular are we gonna find next? The min, the max, Q2, the median, right? We want to find Q2. So how do we find Q2? All right, I just found it. How do we find Q2? It is the median, right? So how do I find it? How do I find the median? It is the middle number. So in this particular example, how do I find it? Hello, anyone home? Find the 2 middle numbers, divide by 2. That is not correct here. Tell me why it's not correct here. Count the data. Oh, wait, it's odd. There's an odd number. How do I find the median when there's an odd number of data points? That's right. In this case, it's odd. So how do I find it when there's 189 data points? Which of the 189 data points is? It is 26, but more specifically, which 26 is it? Q2 is 26, but which 26? Well, it's important because we need to know which one it is to find Q1 and Q3. The right. I'm not sure what you mean by the right. There's a lot of 26s in my data. Which one is the median? In fact, I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. There's 20 26s. So I do agree it's 26, but I have to know which one of those 26s it is. Sixth row, fourth one. So close. So I got sixth row, fifth one. I got the sixth row, the fifth one. So what did I do? There's 189 data points. Which of the 189 is the middle one? What's the middle of 189 numbers? Nope, not 94.5. That would make it an even number of data. With an odd number of data, the middle one is the 95th. 94 on this side, 94 on that side, 1 in the middle. 94, 94, and 1 is 189. It's a 95th. And the 95th data point, there's 18 per row, is 5 rows of 18. And then the fifth one in the sixth row is the median, 26. So I'm going to share my screen here. And for me, it is this one. How do I, yeah, that one is the median, which is the 95th number. Now that I have that, how do I find Q1?
It's in the middle of that 26 and 12,
Yes.
but not counting that one.
Right. So I don't count that 26, which means I look at the 94 numbers to my left. Right, to the left of 26, but we want to know specifically which one. So I look at the 94 numbers to my left. 94 is an even number. So where is the median between which two? Of 94 data points, between which two would the median be? And I have someone saying, well, it can't be an odd number because 94 is an even. It's got to be between two of them. Remember, you don't count the median itself. You don't count that 26. You look at the 94 to the left, which is an even number. So it's going to be between two. Which two is it between? It's between the 47th and the 48th. 94 divided by 2 is 47. So that means 47 and 47. After the first 47, before the next 47. That's 47 and 48. It's halfway between 47 and 48. So 18, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48. The average of these two numbers, Q1 is equal to 23. Not 24, I got 23. And then on the other side, here's Q2. How do I find Q3? Well, there's again going to be 94 data points. So it's again going to be between the 47th and the 48th. 18, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48. The average of these two numbers, I get Q3 is equal to 30.5. I hope that makes sense. Okay, so that's the 5-number summary. Then it says draw a box plot of these data. Do y'all remember how to draw a box plot? Okay, so let's draw a box plot. How should I start my box plot? By drawing what?
A number line?
Draw a number line. Okay, there's my number line. Where should I start my number line at? What's a good place to start?
Q2.
Sorry, I can't hear you. What?
Q2.
No, you don't start the number line at Q2.
Or is it the min?
Well, I would do it slightly past the min. So I would start at 10, let's say. And how far do I want to go?
Past the maximum.
So what's a good number to stop at? So 60, okay, 10, 20, 30, 40, 50, and 60. You can admire my masterful equal spacing later. So how do I, now that I have my number line, that's pretty amazing. Wow, I learned how I did that. All right, so now that I have my number line, what should I put either above or on the number line? Tell me what to do. What should I make? A line on Q2. So 26 is about there, okay? Vertical line at Q2. What else we got? A line on Q1, which is 23, about there, give or take. What else we got? $30.5, which is about there. Okay. What else we got? Dot on the max. The max is 56, about there. All right, what else? A dot on the min, which is 12, about there. All right, what else? Close the box. Okay, close the box. What else? Draw lines connecting. And scribble. I don't scribble. I draw straight lines. I won best penmanship in second grade. I don't scribble. Unless you meant play Scrabble, which, and then you just spelled it wrong, which would be ironic, but nothing to do with this at all. So that's certainly possible. So this is the box plots. Fill in lines. Hopefully you meant by what I just did. Draw swizzle line from box to max. Swizzle line. I don't know what a swizzle line is, but it sounds like it will be tasty. Like a Twizzler, like a Swizzler. I think we can invent Swizzlers. What would that be? Oh, no, no zigzags. No zigzags here. No zigzags. But I'm a little intrigued by the Swizzler idea. I'll have to ruminate on it. Anyways, what is the shape of the distribution shown by the box plot? Would it be symmetric, left skewed, or it is skewed to the right? Right, so I don't even know how to draw it, but certainly something like this. So skewed to the right. Skewed to the right. Okay. C. Which features of the box plot led you to this conclusion? Which features of the box plot led you to this conclusion? All right, all of you who said right, tell me why. What led you to assume this?
Most of the data points are like in that one selection on the left and it like trails off.
Yeah,
So-
so basically, yeah, you have 25% of the data is on this long tail. It's all spread out versus clumped up for the other three parts. Like lots here, lots here, lots here, and then the rest spaced out in this long area. Exactly. Very, it's almost like it's hard to put into words why, but you can kind of see it. All right. Are any observations unusually small or large here? Let's take a look if there's any if there's any outliers. How would I find out whether or not there's any outliers? What would I do?
The 1.5 times the inner quartile range.
Excellent. Now, I saw a few people say IQR 1.5, take Q2 times 1.5. So that's not right. You don't take Q2 times 1.5. You find the IQR and multiply that by 1.5. First, what is the IQR? Q3 minus Q1, which is equal to what in this case? What is Q3 minus Q1 in this example? We have it on top, Q3 and Q1. So hopefully you can do this, 7.5. And then we do 1.5 times that, 1.5 times the IQR. What does that give us? $11.25. And then we do Q1 minus that number. What is Q1 minus that number? $11.75. And anything past 11.75 is considered an outlier. Are there any numbers past 11.75? No, so no outliers or no suspected outliers on that side. And we do Q3 plus 11.25. What do we get there? 41.75. Are there any numbers past 41.75? Yes, lots of them. So lots of suspected outliers. Lots of suspected outliers. So when they say, are there any observations unusually small or large? When you look at the data, I don't think anyone would say that those numbers at the end are unusually large, but the mathematics tells us that they are considered to be outliers. So they are large enough. Although certainly not as large as I would have imagined they would have to be, oh yeah, definitely an outlier. That's why we trust the math. The math don't lie. Well, except when it does. So are there any questions on that problem? Hopefully not, unless someone vocally says yes, we will move on to question 2.9, which says, actually, ooh, look at this. I guess this is a continuation and we just answered it. It says the exercise 2.7 that we just did, right? That was 2.7, gives the estimated miles per gallon for city driving for the 189 classified as midsize in 2019. Are any of the larger values outliers by the 1.5 times the IQR rule? The answer to that is yes, they certainly are. Although outliers can be produced by errors or incorrectly recorded observations, they are often observations that just differ from the others in some peculiar way. In other words, they might be mistakes. Maybe you wrote it down wrong. Maybe you measured it wrong. Or maybe you did it right and there's just an outlier. In this case, the cars producing the high outliers share a common feature. What do you think that is? I don't know if this is really a mathematical answer. It's more of a just practical knowledge of cars answer. Can anyone
They
get?
drove more.
No, I don't think this is the driving more, because miles per gallon is not about how many miles you drive. It's about, I mean, yeah, miles per gallon isn't about how many miles you drive. It's just how many miles you get per gallon, correct? Driving a lot, driving a little, huh?
Truck or something.
Well, if it was a truck, wouldn't that be, well, I don't know. Trucks drive on diesel, don't they?
Oh, right.
Do you get more anyone know trucks? I'm Jewish. I don't know cars, but does anyone know if trucks get better miles per gallon? Or worse, diesel? I don't know. Is that a good thing or a bad thing? I'm pretty sure it's a good thing. My guess would be that some of these cars are just hybrids or electric cars or not electric, because those don't drive on gasoline, but hybrid cars. Like a Prius or things like that are just naturally more miles per gallon than the rest. Something like that. I don't know. This is not really a math question. This was just like a do you know cars type question. Which is not really my favorite type of question. Hybrids are more eco-friendly. That's right. I drive a Prius. That's right. You know why? Because I care about the environment. Actually, that's not why. I just like to save money on gas. The environment is purely coincidental. Nevertheless, okay. So 2.10. Let's jump ahead to 2.10. So 2.9 was just silly. We're going to go to 2.10. Actually, technically 2.9, I could just throw it in here because we really answered it as part of 2.7. So 2.10. X bar and S by hands. Radon is a naturally occurring gas and is the second leading cause of lung cancer in the United States. Ooh, radon, bad boy. It comes from the natural breakdown of uranium in the soil and enters buildings through cracks and other holes in foundations. Radon is found throughout the United States, but levels vary considerably from state to state. Several methods can reduce the levels of radon in a home, and the EPA recommends using one of them if the measured level in a home is above 4 picocuries per liter. 4 readings from Franklin County, Ohio, where the county average is 8.2 picocuries per liter, were 3.8, 1.9, 12.1, and 14.4. A. Find the mean step by step. That is, find the sum of the 4 observations and divide by 4. They're really taking a lot of the fun out of the problem when they tell you exactly how to do it. That was just silly. But what do you get when you do it? We should all be doing this. Math is not a spectator sport. You cannot lose weight by watching somebody else work out. Trust me, I tried. It doesn't work. It's a horrible system. You got to do it yourself. Part B. Find the standard deviation step by step. Yes, 8.05. I agree with all of you. Find the standard deviation step by step. That is, find the deviation of each observation from the mean, square them, obtain the variance, and the standard deviation. So we did this. Let's make a table of our deviations. Deviation 1, deviation 2, deviation 3, deviation 4. So what are our 4 deviations equal to? What is deviation 1 equal to?
I got 18.06.
For deviation 1?
Yeah.
Or for the square of deviation 1?
Oh yeah, for the squared.
So what
The
is
deviation then is negative 4.25.
negative 4.25? So when you squared it, what did you get again?
18.06.
Was that exact or did you round?
I rounded. It's 0.0625.
All right, so 18.0625. We always want to include as many decimals as we can so that our final answer is as accurate as possible. What is the second deviation? Anyone? What is the second deviation?
Is it negative 6.15?
Negative 6.15. And what is the deviation squared?
37.8.
37.8.
225.
225. What is the third deviation? And please, everyone, don't feel like you have to let someone else talk. You know, you're more than welcome to contribute yourself and you know, be a willing participant verbally of this mathematical experience that we're all going through together. What's the third deviation?
4.05.
And what is that squared?
16.4025.
And what is the fourth deviation?
Six 6.35.
6.35. And what is that number squared?
40.3225.
So now that I have the squares of my deviations, what do I do with those four numbers? And what do I do with the squares of those four numbers?
Add them and divide by 3.
Add them and divide by 3. Let's first add them. What do I get when I add them? Anyone?
112.61.
112.61. So if I take 112.61 and divide by 3, I get 37.536 bar. And this is S squared, or the variance. And therefore, what is the standard deviation equal to?
Six point 13.
About 6.13. Okay, that's how you do it by hand. The part C says do it on your calculator. So let's see if our calculator gives me the same thing. Everyone remember how to do this in your calculator? Okay, and then that and that. Yep, I just got it. So that's how long it took me. It's that. Yeah, it's that. That's the first step. After that, edit, and then put in data points in L1. Fantastic. And then hit enter. I love it. Keep going. You're doing great. It's that again. Click calc. Hit one var stats. And calculate. Awesome. Obviously, hopefully, obviously, it's a lot faster to do via calculator than it is by hand, which is why we have the calculators do it for us. All right, 2.15. The 2019-2020 roster of the New England Patriots winners of the 2019 NFL Super Bowl included 10 defensive linemen. The weights in pounds of the 10 defensive linemen were given by those 10 data points. The mean of these data is A, B, or C. So without shouting out the answer, use your calculator to compute it. Got it. That's literally how long it should take. No superior knowledge of math helps here. It's just a matter of plugging it in. So I'm going to give you a couple more seconds though, as I check the score in the US Open, which is just more important than all of you. Anyone here follow the US Open? Anyone, any tennis aficionados here? Anyone really into tennis? No one? No one. That's just a shame. I like playing tennis. I like playing tennis too. The answer is B, 285. Okay, that's just a matter of adding them up and dividing, but not watching it doesn't make sense. Hold up. Hold up. What doesn't make sense? I don't even know if I want to hear this answer. Because like the score doesn't make sense. Okay, I'm not really following you on that. It's negative. It's negative. What's that? What are you saying? I don't know what you're smoking, but I want some. That's all I can say. Well, you're formulating an answer to that because I have no idea what you mean. We're going to go on to 2.16, which is the median of the exercise of the previous problem. What is the median? Well, hold on, I didn't do it yet. Don't write the answer down. I gotta do it. Okay, now that I've done it, what is the median of the data? It is A. In order to get that answer, what do you have to do first in order to get that answer? Put the data in order. Now, how many data points do we have here? 10, which means after you put them in order, where is the median located? After you put it in order, where's the median located? Between 5. Okay, well, we'll answer that question in a minute. But it's between the 5th and the 6th. Two middle numbers divided by 2. So when I look here, I see 1, 2, 3, 4, 5, 6 numbers in the 200s, which means I'm going to look for the two biggest, which are 280 and 275. It's halfway in between. 277.5 is the answer. Or you can actually write them all out and do it that way. 2.17. What is Q1? So just for clarity here, I'm going to put them in order. So let's see. I have 250, 250, 260, 2 275s, 280, 2 300s, 315, and 345. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 of them. I've already established that Q2 is 277.5. I look to the left of Q2. I take the one in the middle. So the first quartile Q1 is 260. A. 260. Good. You guys all got it. I was still working and you all have write it out. So that's amazing. I love it. 218. If a distribution is skewed to the left, A, the mean is less than the median. B, the mean and the median are equal. C, the mean is greater than the median. A, B, or C. Hold on. I'm going to put, so our 2.18. Okay. So now any answers after 2.18 are answers to this question. So if a distribution is skewed to the left, A, the mean is less than the median. B, the mean and median are equal. Or C, the mean is greater than the median. In terms of your golf question, a negative, you can't have a negative answer, but what you can say is that I am 2 beneath you. So that's I won because I'm -2 relative to you, something like that. Anyways, I have an A. Do we have anything else? I literally forgot we were talking about tennis, not golf. I got a C. Ooh, we got an argument here. Fight, fight, fight. Love it. What else we got? Let's get some other ones. Just A and C so far. I'm still waiting. Where are the other ones? Ooh, I got a B. Okay, so what do we got mostly? C, B, C, A, C, A. Lots of A's. But I got some B's and some C's. So a distribution is skewed to the left. Skewed to the left. Looks like that. The peak was here. Where is the mean going to be pulled? In which direction? Where is the mean going to be pulled in which direction? Left. Where's the median going to be pulled in which direction? Also left.
So,
Just not as much. Slightly left. Oh, someone said farther to the left. The mean is pulled more than the median. So if it's skewed to the left, the mean is pulled more to the left. Therefore, A, the mean is less than the median. 2.19. It's red and it's starred. I don't know what that means, but this is a very important question. What percentage of observations in a distribution are greater than the first quartile? 25%, 50%, or 75%? 2.19. A, B, or C? Greater than the first quartile. 25%, A, 50%, B, or 75%, C. What do we got? Nothing. Nobody knows. We got a C. We got one C. Where's everyone else? C, 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 C. Oh, now we got peer pressure. But the answer is C, because remember, if you look at your box plot, 25%, 25%, 25%, 25%, at least approximately. So if this is the first quartile right here, what's to the right of it? Approximately 75%. C. 2.20. To make a box plot, you must know A, all the individual observations, B, the mean and the standard deviation, or C, the 5-number summary. What do you need to make a box plot? C, 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 C. Lots of C's. So the answer is C, although it's a weird question because technically you can get it from A. If you have all the individual observations, you can compute the 5-number summary, but you don't need all the individual observations. All you need is the 5-number summary. So actually, I changed my mind. It's a great question. All right, 2.21. The standard deviation of the 10 weights in exercise 2.15. Use your calculator. Ooh, so let's go back. Let's find the standard deviation on my calculator of these 10. I'm gonna do it right here. 275, 300, 300 again, 315, 345, 260, 250, 275, 280, and 250. Check my work. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Boom, boom, boom. And got my answer. So this is 2.21. Okay. A, B, or C. So 2.21. A, B, or C. I have a B, 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 B. B, B, B. Well, if you use your calculator, then it's pretty straightforward. Well, not really. Well, it is straightforward, but be very careful because look at what your calculator says. What does your calculator say under SX, which is, by the way, 30.28? Just beneath it, your calculator gives this. Right? You all see that? That's not the sample standard deviation, but it is a standard deviation. It's just not the one that we're doing yet. So it will play a role later. But right now, the only one that we're dealing with is SX, which your calculator gives you to be 30.28. So that was B. Ooh, this is a good question. 2.22. Because I don't think I actually mentioned this in class, or did I? No, actually, this is not a bad, never mind. We didn't do this in class. What are all the values that a standard deviation can possibly take? A, S must be greater than or equal to 0. B, S must be between 0 and 1. Or C, S is between -1 and 1. So this is 2.22. What are all the values that a standard deviation can possibly take? And before you say B, look at the previous problem where we got our standard deviation as 30.28. Like, so just like literally 8 seconds ago, we got an S value bigger than 1. Right? Yes, Mary, I see you a little embarrassed there. Just a little bit. So a star. Oh, correction. I see. Of course it did. Of course, yeah, of course. So we got lots of A's. Tell me, why is it not C? All of you who wrote A, why not C?
I don't think it can be negative.
Okay, great. Well, so there's 2 reasons why it can't be C. One, we just got 30.28, so that doesn't work. But also remember that we took a square root to get S. You can't get a negative after square rooting something, at least with real numbers that we're used to. So the answer is A, S must be positive or 0. By the way, when would S be equal to 0? What is the one and only situation when S will be equal to 0? This is an important one. What is the only situation when S will be equal to 0?
If there's only one data point.
That's true. Okay, so I rephrased my question. Other than the situation when there's only one data point, when is the only other time that S will be equal to 0? The problem with only one data point is it doesn't even make sense to compute S because you can't divide by 0 in the square root. So that doesn't even make sense. But other than that situation, which we're not going to worry about, what is the only other situation when S will be equal to 0?
Is it if every data point is 0?
No, but close. It's if all, no, that's not it either. It's if all the data points are the same. If all the data points are the same, then they're all equal to the mean, which means all deviations are 0. which means all squared deviations are 0, which means when you add them all together, you get 0. Because think about it like this. S is how spread out the data is. When would the data not be spread out at all? If every single data point was exactly the same. Correct? So the lowest S could be a 0 if they're all the same. Otherwise, it will always be more than 0. Hopefully that made sense. 2.23. What are the correct units for the standard deviation in exercise 2.21, which references the weights in exercise 2.15, which were in pounds? So with the original question being in pounds, what are the units of the standard deviation? Is it no units, it's just a number? Is it pounds or is it pounds squared? A, B, or C? Standard deviation, no units, pounds, or pounds squared? A, B, or C? I got a B. Anyone else got one? B, 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 B. Lots of B's. Now we got to worry about peer pressure. B spelled B-E-E. Let's see. So the answer is B. That is correct. The spread of your data is going to have the same units as your data. And if you work through the problem, the first thing we do is we calculate deviations, correct? How far you are from the mean. If the mean is 100 pounds and you're at 110 pounds, you're 10 pounds away. When you square that, because we square the deviations, you get pounds squared. But then what's the last thing we do at the end of the problem? We square root, which is back to pounds again. So the standard deviation will have the same units as the original data, and that's always the case. 2.24. Which of the following is most affected if an extreme high outlier is added to the data? The median, the mean, or Q1? This is 2.24. What is most affected if you add a high outlier? The median, the mean, or Q1? The answer is the mean. It's B. It is a non-resistant measure. The first quartile is, first of all, the median is resistant, and the first quartile is on the other side of the median. So it's even more resistant to high outliers. All right, so 2.24 is done. And finally, we now have 2.36. Never on Sunday, also in Canada. Okay, I don't understand what's going on. So let's take a look. Exercise 1.5 on page 19 gives a number of births in the United States on each day of the week during an entire year. The box plots in figure 2.7, there's 7 box plots, 1 per day of the week, are based on more detailed data from Toronto, Canada. The number of births on each of the 365 days in a year grouped by day of the week. Based on these plots, compare the data of the week distributions using shape, center, and variability. Summarize your findings. First, even before we answer their question, when people are pregnant and give birth naturally, without worrying about being induced or anything of that nature, do you think there's any reason naturally why people would be more likely to be giving birth on one day of the week than any other? Just naturally, right? Go back
No.
hundreds of years, right? No, every day of the week, what would change one day of the week from the next? But if you look at the data here, there are 2 days of the week for which there's significantly fewer births than the other 5. Which 2 days of the week have significantly fewer birth births than the other 5. Yeah, Saturday and Sunday, the weekends. As if the babies kind of know, oh, sorry, you're watching the Kardashians or football or whatever you guys do on weekends. Oh, you're playing Fortnite or, whatever you kids do, time to rest on weekends, right? So why is it that the data would seem to suggest that fewer births are on Saturdays and Sundays versus the rest of the days of the week? Why should the data be the way it is? What's a realistic reason why that should be the case? Doctors want the weekends. That's 100% true. Why would a doctor schedule a birth on a weekend if he doesn't have to, or she doesn't have to? Because nowadays, babies are induced. There are scheduled cesarean sections and whatnot. So that's 100% true, right? If you just left up to nature, it should be even across the week, but it's not fully left up to nature. So that's 100% correct. Doctors want to play golf or whatever they do on weekends. So yes, 100%, that's why. Nevertheless, let's now answer to the question. Compare the day of the week distributions using shape, center, and variability. Let's do shape. Which of these are symmetric or nearly symmetric? I got a Thursday. Thursday seems nearly symmetric. Any other ones? Oh, that's another one that's pretty symmetric. Sunday. Oh yeah, Sunday's pretty good. Any other ones? Friday looks very symmetric. Almost the most symmetric. Possibly. Okay, which ones are right skewed? By the way, I think Wednesday is fairly symmetric. No, Wednesday's not. Okay, right skewed. Which ones are right skewed?
Monday and Wednesday.
Monday looks right skewed. You said Wednesday? Yeah, Wednesday looks right skewed. Yeah, anything left skewed?
Tuesday.
Yeah, well, oh yeah, definitely Tuesday. Oh yeah, Tuesday's a big one. Thursday is kind of, yeah, Thursday is fairly symmetric, I think. I mean, a little bit, but I don't see that much of it. Nothing, it doesn't really stand out. I mean, maybe a little bit, slightly, but I don't see a huge amount. Now let's talk about in terms of centers. Do they all have the same center? What day of the week is the most popular day of the week for births in terms of center?
Tuesday.
Tuesday. Yeah, Tuesday.
Can we
Tuesday.
say like the median of a couple days is kind of the same?
I'm sorry.
Like group them?
Say that again, please.
Can we group them and say for these days the means are approximately the same?
Yeah. I mean, I would say Thursday, Friday, Tuesday, roughly the same. And Wednesday, those are all fairly close to each other. Monday is a little lower, and Saturday and Sunday are the least on average. Right? That would be a summary of the data in terms of center. And variability. Are some days more variable than others?
Yeah,
Which is the most variable?
Thursday.
Thursday is certainly the most variable. Sometimes there were 60 births, sometimes it was 130 births. So Thursday was all over the place. Which one's the least variable? Saturday looks like. So, you summarize it in words, this is the most variable, followed by this, something like that. I don't really like open-ended questions like these. I like questions with definitive answers. usually mathematical numbers and whatnot. But doesn't change the fact that you're gonna have some questions like this in the book and on homework, although usually a multiple choice. All right, so are there any questions on what we've done? We have finished chapter 2 in its entirety. We will start chapter 3 on Tuesday of next week. Don't forget, there is a mini quiz next Thursday. Our first mini quiz will be, this is Math 140 Science, so it will not be in class. It'll be assigned and due after Tuesday. It'll be due on Wednesday. So you'll have, I don't know exactly when it will open. It might already be open because it's within 7 days. If not, I'll check it, but it'll be due on Wednesday, the 15th. Just look at it. You'll see the due date. But yeah, it opens this week. Well, let me look at it right now because according to this mini quiz, it does say hidden. So let me see when this one is going to open. It says due Wednesday, September 15th. Let's take a look. When's it going to open? I'm going to open this. Aha, it's already built in. It is visible on September 15th at 12 a.m. until 11:59 p.m. So it'll be open literally all of Wednesday from 12 a.m. till basically 12 p.m. Okay, so our class is Tuesday. Our class ends at 5:30, give or take, and it will open that midnight. Okay. Other than that, the first homework is due today, as is the first practice quiz. Second homework is up and will be due on the 20th. And yeah, that's all she wrote. So we're going to end a little early today. I'm going to stop recording.